Okay, so far we looked at currents at a node. Now we are going to look at voltage around a loop. Okay, and this is better. The idea is that the sum of voltages around any closed path equals 0. Okay, and I'm not going to elaborate on that theory there. It is better explained using an example. Okay, this is the idea of conservation of energy. So let's see if I have a circuit that looks like this. Okay, there are a bunch of different closed paths here. First of all, let me try to identify the closed paths here. Okay, there is one path that looks like this. Okay, let's see if I can do that. Okay, so there's one path that looks like this. Okay, let's see if there are more closed paths. Sure enough, there are a ton of closed paths here. So look at this guy. That's a closed path. Okay, so in other words, any closed path is a path that begins at a node. For example, let's say I want to begin at this node. Okay, goes around and comes back and ends at the same node. Okay, I'll give you an example here. Let's see, let's pick a different color, this guy. So beginning at that node, okay, right there, I'm going to traverse a path and end at the same node. That's a closed path. Okay. Similarly, I can think of any number of closed paths here. There's more than one closed path. This guy. That's a closed path too. Okay. So typically what we do is there may be often be more closed paths than I need often, right? So this guy is a closed path. Okay. So there are a bunch of different paths. So this is called a loop. Okay. A closed path is called a loop. Okay, so Kirchhoff's voltage law is applied around a loop. Okay, and let me show you. We add the voltages around the loop, add the voltage drop around the loop, and equate them to 0. Okay, we'll pick one loop for example. Okay, one loop that begins here and ends like so. Let's call this loop A. Okay, let's call this loop A. Okay, the way you apply Kirchhoff's voltage law is to begin at the lower left corner of the loop, lower left corner of the loop, and go around the loop once. Okay, go around the loop once and add the voltage drops. Okay, this is what I'm going to do. So pay attention. I'm going to follow this path here, begin over there, traverse through all the elements in the loop. Okay, so first in my traverse, I find this resistance, okay, showing a voltage drop negative to positive V1. So I add a negative V1 over there. Then I see the resistance, 2 ohm resistance with a plus or minus V2 over there. And it clearly shows a positive sign on V2. So I add a plus V2 over there. So that's the here. Then I come to the 4 ohm resistance with plus minus signs shown like so. So plus 4, sorry, V4. Okay. So I'm going element by element. Okay. One by one. I'm traversing all the circuit elements one by one in this path. Okay, what's the next element? The next element is a voltage source over there with the negative and positive sign. So the negative comes first. So I'm going to do a negative VB. Okay, and then there is this guy. Then there is a negative VB. Excuse me. Then there is this guy, negative positive V3. Okay, so negative V3, all of that equals to 0. So around the loop A, negative V1 plus V2 plus V4 minus VB minus V3 equals to 0. That's the idea of Kirchhoff's voltage law. You add the voltage drops around a loop, that should sum to 0. Okay, earlier Kirchhoff's current law, you add currents at a node. Okay, when you add currents at a particular node, that summed to 0. Here, when you add voltages around a loop, that should sum to 0. We'll do another example here. Let's see. Let's pick another loop. Loop maybe that's like so. Okay, let's pick that loop. So I think this loop is already called as loop D. Let's not loop, let's call this loop E. Okay, that's not shown here. Let's do loop E. Begin at the lower left corner, okay, and follow the circuit elements. Then the first circuit element that you see is the 6 ohm resistance in here, okay. The 6 ohm resistance, notice the polarity plus minus V6. So that comes first, plus V6. Then I follow the path to find a 7 ohm resistance. Plus comes first, plus V7. Okay, and then I look at the VD. Negative comes first, negative VD equals to 0. So this is KVL around loop E. Okay, that's something that we just um, defined to be a loop.